All right, example 5. This is a fun one. A diver on the ledge of a diving platform jumps 2 meters into the air, then falls to the water below. The time for the entire dive was 3 seconds. Part A, at what speed did the diver leave the platform? So first thing we're going to want to do here is have some sort of diagram just to organize our thoughts. So here I'm going to draw this, where here this is the surface of the water. And let's go ahead and just say that this is a value of, let's just say this is a position of s equals 0. Okay. And now we can visualize the diver taking some sort of path like this. Jumps from the platform into the water below. So of course the diver is moving horizontally, but the only thing that we're going to actually use here is how the vertical distance changes. We're not going to actually track anything about horizontal motion, just vertical motion. But just to make the picture accurate, this is the picture that we'd have. So now what I want to do here is go ahead and say that if we're going to treat the surface of the water as what is 0, then that means the diver actually jumped from some initial height. So this is actually some initial height, S0. We don't know what that is. We'll go ahead and, of course, say that the diver we start our stopwatch at the time the diver jumps off the platform. So then here, when the diver reaches its maximum height, we have some time that we need to know. This is the maximum time. And then later on, we have t, let's just call this t final, for when the diver makes impact with the water, and we're told that this is 3 seconds. Okay, the last thing we're told is the fact that the diver's height, so this amount here, was 2 meters. So out of everything that they've told us in the problem, we've just sort of stripped away everything that we don't need, and we have very easy to read and see what we do need. So we need to know at what speed the diver left the platform. So ultimately, we need to know the velocity. Okay. So let's go ahead and write down our kinematic equations based on what we know so far. Is there anything that we can fill in? So S of t, we do not know the initial height. We don't know that, so we just have to leave it as S0 for now. We don't know the initial velocity. That's what we're trying to figure out in this part A. We do know g, just because it's a constant, but that's it. Okay? So what's v of t? V of t, this is going to be initial velocity, which we don't know, minus gt. So there's nothing that we can actually fill in on these two, in these two equations. Okay, well, what do we know? We do know what the max height is actually, kind of. So here's some other information we do know. So the max height is whatever the initial position is, plus the 2 meters that the diver rose into the air. So we don't concretely know what it is, but we do have a way to relate the maximum height to the platform height. So let's go ahead and do that. So furthermore, if the maximum height is reached at this t maximum, then this means that when we plug in that time value for t max, this is going to equal S0 plus 2. That's really taking this thought here and then encoding it into something that's a little bit more computationally friendly. Okay, so that's good. Maybe I'll just say i.e. this. Okay. So what we can do now is let's figure out T max. That sort of gives us a guide here. So what do we know about T max? We know that at the time of maximum height, the velocity must be 0. So we can go ahead and then we can go ahead and take a look at the velocity equation. So this would be v naught minus gt max. So we know that the time that corresponds to the maximum height is just the diver's initial velocity divided by the acceleration due to gravity. Okay? And that might feel like, well, hey, we don't actually know anything now. This is just defining things we don't know in terms of other things that we also don't know. And that is true. For right now, this doesn't seem like it is going to help us very much. But here's the thing. We actually have a way to relate the two. How? Well, right here. Let's go ahead and plug this expression v naught over g in to s and set it equal to what we know it is, s naught plus 2. So since s naught plus 2 must, the maximum height, this must equal what we get when we plug in v naught g into s of t. This would be s naught plus v naught times v naught over g minus 1/2 g v naught over g quantity squared. Notice here that the things that we don't know nicely cancel out. So then we just left over with 2, and then here we have v naught squared over g minus 1/2 v naught squared over g, which is simply v naught squared over 2g. So our initial velocity, v naught, is, we can multiply this 2g up to the other side to get a 4g, and then we'd have to square root it. So this would be plus or minus 2 square roots of g. But because the diver jumped upward, we know that this has to be the positive root, not the negative root. So we'll just go ahead and simplify that to 2 square roots of g. So this is about 6.3 meters per second. Part B, how high above the ground was the platform? Well, let's see here. What do we know? We do know that 3 seconds, at t equals 3 seconds, the position must be 0. So we know s of 3 must equal 0. So we can go ahead and fill this in. This gives us 0 equals s naught plus 3 v naught minus 9g over 2. Okay, notice here we do know what v naught is, so we can plug that in, and we can also plug in g here if we wanted to. I usually just plug it in right when I get the decimal, otherwise I just leave the answer written in terms of known constants. It's easier. So I'll keep things written in terms of the known constants. I'll just work on solving for this s naught. So if we solve for s naught, the initial position, the initial height, we should have 9g over 2 plus 3 times our v naught. And what's our v naught? Our v naught is 2 square root of g, so this would be 6 square roots of g. And if we go ahead and get a decimal for that, we end up getting 25.3 meters. So I don't think this is, I don't know much about diving, but I don't think this is a realistic problem. With the, that's about 75 feet for a dive. Maybe it is. I don't know. Seems tall to me. So what's the diver's impact velocity? So impact velocity here, well, we know that the diver hits the water at 3 seconds, so if we plug in 3 to our velocity, we should get the impact velocity. So v naught is 2 root g minus gt. So minus 3g. That is approximately negative 23.1 meters per second. So moving 23 meters in 1 second, that probably hurt a lot if not landed properly. Again, I don't know much about diving, but that is fast. Okay.